Okay, lesson 5.1a. We're going to talk about exponents, and we have 7 exponent rules that we're eventually going to talk about today. So first off, there are two parts. There are two parts here. This little guy. Does anyone know what y is? What is y? Like how would you? That is a. It is an exponent. Yes. That right there is an exponent. Exponent. All right, and what is x? There's a vocab word. There's a. What do we call it, Janet? It's called a base. I feel like I'm a base. Alright, so we have an exponent, we have a base. So what I want you to do, I want you to take 15 seconds. I want you to think in your head, what would your rule be for exponent using the word base and the word exponent? What would be your rule? Go ahead and just think about it for a second. Don't share with anybody yet. Think about it for a second. Think about it, Isaiah. To yourself. 10 seconds. Share with someone around you. What would your rule be using the word exponent and base? So go ahead and share with somebody. So here are a couple good things. So let's start with the boys in the back. Evan, what did you guys come up with? Jonathan, you should not have that out.
Exponent is the amount of time that you have to multiply the base by itself.
Okay. What did you guys come up with over here? David? What did you guys say? Okay. All right. Anybody else have a different type of phrasing that they want to share with the group? All right. So I like both of those. So let's just say the base multiplied by itself. Oops. By itself. So we take the base, we multiply by itself as many times as the exponent itself. Many times as the exponent itself. Kind of like a benevolent overlord. What's up? I didn't see. I'm not seeing the. Apparently, I have to watch people. It was amazing. Okay, for example, if I had 2, we do this one, 2 to the 4th, well, that's telling me to take 2, to take the base and multiply by itself as many times. So take 2 times 2 times 2 times 2, which would equal 16. There are 2 types of forms that I wrote up here. I have the one that I boxed and I have the one that I'm boxing. Right. Does anybody know what either of those 2 forms, how you describe either one of those 2 forms? Do you have a question? You really need my mojo right now? Jump in. Oh, now we're going. There's a reason that works, because 2 times 2 is 4, and 2 times 2 is 4. So you can combine that and say 4 squared is 16. But no, that doesn't work. That's a very good observation. Okay, so what if I gave you some hints? One of these is called expanded form, and one of them is called exponential form. So let's pick on somebody here. Angel, which one do you think is expanded form? The red one, yeah, the 2 times 2 times 2 times 2, right? Because it's expanded out. So what is expanding? Like if you expand a balloon, it gets what? Bigger, right? So it expands. Well, hopefully these don't pop. So they can mess these pretty quickly.
Oh.
So then, Jonathan, which form is the exponential form? Yeah, 2 to the 4th. That'd be easy. So those are equivalent forms. So can someone remind us, what does equivalent mean? The same, yeah, I mean the same, right? They're equal. Those are equivalent forms. So, our rule in this class for simplification, alright? So our rule for simplification. So you're wondering, like, 13 to the 7th, do I have to multiply that out? 2 to the 3rd, do I have to multiply that out? So here's your little rule for simplification. If it's anything to the 4th power, you're going to multiply. If it's to the 5th power, you're not going to multiply. So here's what I mean, for those of you who have no idea what I'm talking about. If you had 3 to the 4th, you would need to say that equals 81. If you had 3 to the 5th, you're going to be able to leave it as 3 to the 5th. Alright, so what does that mean? So if it's a number, an integer, to the 1st, 2nd, 3rd, or 4th power, I want you to multiply it out. If it's an integer to the 5th power or above, you don't have to multiply it out. Alright, so what we're going to be working on, we're going to work on simplifying these things, so we need to know what you're saying. So that's what we're saying. Got it? Yeah, I mean, it'll be, as we go through examples, it'll be obvious, like, what this means. So just let us know that. Yes, sir? Times them together? Yeah, like if you had, like, 2 cubed times 3 to the 4th, you would say this is 8 times 81, and then you would want to say that equals 648. So yeah. Okay. Don't worry, on all these types of things, you're not going to get anything like too far out there. You know, 17 times 69 to the 3rd, it's not going to be anything that's ridiculous. Okay. All right. So we have 7 rules. So we have 7 rules. All right. Tomorrow there's going to be a little mini quiz when you come in. And it's going to have all those rules on it. If you don't have these rules, the faster you get these things memorized, the easier life is when it comes to simplifying. Alright? So I'm going to give you all of them today, and then tomorrow when you come in for bell work, I'm just going to ask you which one. It's going to be a multiple choice thing on your clicker. Alright? So we'll give you the opportunity to get some mini points. Alright, so we have 7 rules, so let's start with the easiest one. Let's start with the easiest one. The easiest one is called the zero power property. Easiest one is the 0 power. The 0 power property states that anything to the 0 power equals 1. Anything to the 0 power equals 1. We'll do a little lesson on why that works a little later. We'll do a couple more things. So the 0 power property states that anything to the 0 power equals 1. You can see here, 1 billion to the 0 equals 1. This horrible looking thing right here, it's all raised to the 0 power. So if it's to the 0 power, it equals 1. Jada, if it's to the 0 power, does it equal 0? No, it equals 1. So Jeff, if it's to the 0 power, does it equal 0? No, it equals 1. Right? So Mondo, if it's to the 0 power, does it equal 1? Yeah. I can tell you how many students will write 0. Anything to the 0 power equals 1. So, true or false? On your clicker. Anything to the 0 power equals 1. True or false? Anything to the 0 power equals 1. True or false? True. 1, 2, those 3 days. 4, 5, 6, 7 today. 8. David, you click in. Did you? I think you're 9. All right. Anything to the 0 power equals 1, true or false? Good job, everybody. No. 0%. Good. Good. Anything to the power equals 1.
If someone has 1, I would say that person.
All right. Now we're going to do the really hard one, the negative power property. This is the really hard one. This is the negative power property. All right. The negative power property states that what you have to do is if you have anything to a negative power, here's what we're going to do. We're going to hop the line and switch the. We're going to hop the line and switch the sign. Here's what that means. So if we look at our example over here, we can write this as a to the negative n over 1. So when it says hop the line, this is the line. When it says switch the sign, this is the sign. So you can see it went from being a to the negative n over 1 to 1 over a to the n. So all you do is if you have a negative power, you just take whatever that negative power is attached to. If it's on top, you move to the bottom, make it positive. If it's on bottom, you move to the top, make it positive. So you hop the line, switch the sign. Hop the line, switch the sign. Hop the line. Let's go ahead and let's look at this example right here. Let's go ahead and look at that example. Go ahead and just copy that full example down. So you can see here we have 5 to the negative 2. We have 5 to the negative 2. So 5 to the negative 2, what we do is we hop the line and we switch sides. So we take the 5 to the negative 2, which is on top, and we put it on the bottom. When we put it on the bottom, you can see there's a little visible 1 there. And we've actually worked a lot this year. Think about when we did slopes, when we did the lonely variable substitution. We know that there's nothing there, right? We have a little 1 there. Okay? So we have 5 to the negative 2. That equals 1 over 5 squared, right? We just want to hop the line and switch the sign. And then this is what I was talking about when I told you I want you to simplify. So the exponent on the 5 is 2, which is less than 5, right? So we multiply 5 times 5, we get 1. All right, so we got another example here. That says z squared divided by x to the negative 3. I would caution you on this one. The only thing you move is whatever is attached to the negative exponent. That's the only thing that gets moved. What? Yeah. That's the example 2. Oh, I see. Yeah, no, that's confusing. Yep. That's example 2. EX2, that means example 2. So we're on the same page here. Okay, so what you wanted to do is you wanted to bring the x to the negative 3 to the top and make it positive. So you get z squared times x cubed. So you get z squared times x. C squared times x. Alright, go ahead and try these together. Alright, so could someone walk us through the first one? Joshua, could you walk us through the steps you did for the first one? Okay, we do first. Okay, so what did you get when you did the negative power property? Good, so you can see the negative power property, you hop the line and switch the sign. Okay, we do that. Good, so you multiply 7 times 7 times 7. Alright.
And I got
1 over 340. Okay, what's up? Yes, you keep it down there. Right? You moved it down there, it no longer has a negative sign on it, so it's going to stay underneath the line. Okay, so did you walk us through how you did the second one? Alicia, can you walk us through how you did the second one? Sorry. Okay. How did you get that 2 cubed on top of it? Yeah, right. You hop the line, you switch the side. Hop the line, switch the side. Alright, what did you do? Okay, what is 2 cubed equal? Okay, done. So what was your final answer? So this is what we have right now for Alicia. We have x squared times 8. Jeffrey, is there anything else that we can do to x squared times 8? No. No. Okay. What's your answer, Alicia? People may have written it as 8x squared. Those are the same thing. Those are equivalent. So you're used to maybe seeing the coefficient first. So you may put the 8 in front of the x squared, but those are both. Thank you, Joshua. Alright, just a negative power property. Alright, negative power. Alright, so now they definitely get much easier. This is the product of powers properties, which I am going to call the product. The product. So the product rule states that if you have like bases, right? Remember Jada told us that this spot right here, that's called the base, right? And they're the same, so we call them like bases. So the product rule says if you have like bases, like bases is kind of a new term there. Like bases. If you're multiplying like bases, you add the exponent. That's what it says right here. If you're multiplying, right, that's a multiplication symbol. If you're multiplying like bases, you add the exponent. So if you're multiplying like bases, you add. So here is an example of what that looks like. You can see I spelled out example, so it doesn't confuse anybody. So we have 4 to the third times 4 squared. So 4 and 4 are like bases. So if we have like bases, we want to add the exponent. So if we have like bases, we want to add the exponent. 3 plus 2 is 5. So in this case, you would not need to multiply that out. You would not need to multiply that out, because that's the fifth power. So 5 is greater than 4, so you would multiply that out. So you would leave it at that and use the multiply. All right, let's go ahead and take a look at an example I'd like to use. Way down to the graph. When you have your answer, what is the exponent on the x? Go ahead and click in. Once you have your answer, what is the exponent on the x? What is the exponent on the yeah.
I just want the exponent.
Yep, so just give me the value of the exponent. Let's go ahead and lock you out here in 5 seconds. 4, 3, 2. Look at it, you must click in. Click in, let's go. Something's not here. 10. It's not up, that's fine. Alright, here we go. So it should be 60. So when you write this, you get x to the 5 plus 11 equals x to 50. And so we're going to call that the product. That's the product. The quotient of powers property, which we are going to call the quotient. So thinking back to the product rule, if I have like bases and I'm multiplying them, I add the exponent. If I have like bases and I'm dividing them, Quentin, what am I going to do to the exponent?
Well, if you were dividing.
Yeah.
Dividing the exponent.
Yeah. So we're dividing here. What are we going to do to the exponent?
Okay.
Yeah, we're going to subtract them, right? We always subtract the top from the bottom. We always subtract the top from the bottom. Yep. So we're learning it the correct way. We're not going to make it cheap. So we always subtract the top from the bottom. All right, so go ahead. Let's take a look at this example. So you can see here we have 5 to the 7th divided by 5 to the 3rd. So our rule says we have like bases. We subtract the top number, 7, from the bottom number, 3. 7 minus 3 is 4. 4 is less than 5, so we want to multiply this out. We get 5 times 5 times 5 times 5. We get 5 times 5 times 5 times 5. Go ahead and take a second to work that out. DJ, what is 5 times 5 times 5 times 5? It is 625. So remember, we always subtract the top number from the bottom. So I have 2 for you to try here. So real quick, if I can just have you focus over on me, if there is not an exponent, what is the value of the exponent? If there's nothing there, what number is there? Yeah, there's a 1 there. So in this case, in this problem right here, just so we're all on the same page, there's a 1 right there. So go ahead and try and do both of those. This second one is kind of like a sneaky second step. All right, so go ahead and try both of these. I'm walking around. I can help. Yes. Do you remember what property that is? If it's the same when we go back and forth. Yeah, it's a commutative property. If you can move it back and forth. That Ames stuff, right? That Ames stuff. I use that phone. From geometry.
Yeah.
Helpful, right? Yep.
I want you to be able to check that. Oh, let's see here. Is there a 1 right there? Okay, so it's 3 times 2 is 1, and then 4 times 1 is 6. Yeah. Is it easier or is it on top? You should go on top. This is negative on top. So try and get 11 minus 15. So now we got. Simplify that a little more. Make it powerful. Good job. That's an easy one. Okay, can someone please walk me through what they did for the first one? Garrett, can you walk me through what you did for the first one? Good. So we have 4 minus 1 is what? Good. So we have x to the third, sorry, 5 to the third, x to the third, over 5 squared. And you probably did it in one big step, but we're just going to do it in 2. What did you do next? Good. So we get 3 minus 2 is what? 1. So we get 5 to the first, x to the third. Is that how you were going to say? Okay. So you might have written it like this, or you might have just written 5x cubed. Both. Okay, could you walk us through how you did number 2? Mono, can you walk us through idea number 2? Yeah, so we have 11 minus 13, right? We always do the top minus the bottom. So we get negative 2, remainder goes on top, so we get 7 to negative 2. Did you stop that?
Okay, we'll do that. Maybe. So he hops the line and switches the side. 7 times 7 equals what? Like 1 over 41. I walked around, I felt a lot of people get this, and a lot more people continue on and get to that. Okay. One of the things that you'll see is to have a simplified expression, we don't want negative exponents. Alright, now we have the 3 easiest properties. Alright, the 3 easiest properties. The first one is the power of a power property. Power of a power property. Example number 1 over here. Just so you know, I am getting these uploaded, so if you miss the notes or anything like that, well, you can just search for MVHS. So what it says if we have something like x, let's see the number. Let's say we have something like 3 squared to the 5th power. Right? So 3 squared to the 5th. What we're going to do is we're going to take 3 squared. It's going to be 3 squared times 5. So we get 3, and then what's 2 times 5? 2 times 5 is 10. 10 is much bigger than 5, so that is our simplified expression. Alright, so with that, it doesn't work. That is the power of a power property. Power of a power. Alright, we have 2 more properties to go here. Power of a product. Power of a product. Property. Power of a product. Property. This says if you have some product, like 3 times 4. You have some product like 3 times 4, and that entire quantity is squared. What we do is we distribute the exponent. So we distribute the exponent to everything inside the quantity. So this does not work with addition. This works with multiplication. So not addition, but it works with multiplication. So what I want to do is we want to, I think this gets back to a question you had, Chick, in terms of multiplying things together. So you would, 3 squared is 9, 4 squared is 16, and then, yeah, you would multiply 9 by 16. 9 by 16 would be 144. 9 by 16 would be 1. And the last one. Power of a quotient property. You can see this one looks just like the last two. It has something inside parentheses raised to an exponent. So in this case, all that we have is we have a over b, and the whole thing is raised to the m. So we just distribute the m to both the a and b. So for a little example here, if we had x over y squared, all to the 3rd power, we would bring the 3 in. We would get x to the 3rd over y to the 2 times 3. We get x to the 3rd. 2 times 3 is, so what's this? What's up? No, it should be outside the frame. Because what we're doing is we are distributing these three inside the frame. We're distributing it inside. Are there any negative exponents? So we're not going to flip. You only flip if there are negative exponents.